Today's lesson is going to take a look at solving a system using graphing. When we talk about a system, okay, we're talking about multiple different kind of problems or scenarios which need to happen in order for something to take place. So questions often have multiple problems or scenarios, okay, and the solution is when both of those problems are solved using the same data or the same point, okay? And so there might be two different kind of scenarios that take place or problems. I'm gonna put scenarios on there as well. Yeah, I'll put that in brackets because we can talk about that. So maybe two different scenarios or two different kind of ways of solving a problem or ways of finding the solution. Like we did the bus question the other day. That's two different things, right? So we talked about how there's a number of buses and number of students that are involved. So there's two different kind of criteria that really that go in place there. Each problem or each of the criteria can be seen as a linear function. Okay, the point where the two linear functions crosses or meets is the solution to the question. Or to the problem. Okay, and we can check the solution. We insert the independent variable into the function. The result will be the dependent variable, and it should work out the same for each one. Now, the two linear functions are called a system of equations. Okay, and a system of equations is, again, two or more equations. There's a number of different ways to solve them. The only one that we're going to take a look at in this course here is graphing. There are a couple lessons kind of on top of this that we could go over, but we're not. We're going to talk about just how do we solve them using graphing. So let's take a look at this system right here. We have two equations, and we'll list them off as number 1, which I'll do in brown, and number 2, which I'll do in green. So I'm going to do two of them. I'm going to do them in different colors so that we can definitely see the difference between them. Okay, the brown one, we'll graph it out first. So the brown one is y equals negative x plus 1. So that one is at positive 1 right here. There is our first point, 0, 1. There's our y-intercept. These are both in graphic form, by the way. Negative 1 is our slope, so it's going to go down 1, over 1, and we're going to draw a line through those. I'm going to try to draw it as accurate as possible. The big thing is drawing it accurately to find our answers, and we'll look at how we can do it even more accurate a little bit later on. The second one here, y equals x plus 5, is going to be right here, and it has a slope of 1, so we're doing up 1, over 1 right there. And this one is going to have the line is going to go through like that. So now you'll notice these two scenarios that we have here, these two functions, they cross. And the point where they cross is right here. This looks like a very nice point. It looks like it's at negative 2, 3. So I'm going to label that as negative 2, 3. Sorry, I forgot to label this one here, 0, 5. Okay. The point negative 2, 3, it looks as though that is where the solution is. And we're going to label our graphs here too. This is y equals x plus 5. And this one here is y equals negative x plus 1. Negative 2 over 3 looks like it's the point where they meet. That means that both of these equations have the point negative 2 over 3 in them. We can test that out by plugging them back into the equations. So let's look at number 1 here. So the point negative 2, 3. Let's put it in here. 3 is equal to negative 2 plus 1. Negative 2 is positive 2. Plus 1 is 3. So this is 3 equals 3. That one checks out. It works for our brown equation, which we would expect it to if we've graphed it out really nicely. For our second one, let's see if it works again. So we're going to put the point in. 3 is equal to negative 2 plus 5. negative 2 plus 5 is positive 3, so this is 3 equals 3. That works out. It works out for both of our questions, okay? Which is really good. That's what we want, what we wanted to, okay? It's supposed to work out for both of them. This is solving this system using graphing. Now again, I said there's a couple different ways that we can do this, but we're only going to look at the graphing method for this course here. If the solution, okay, so this goes into a little more here, if the solution is a nice value, okay, we can assume that it is an exact value. Okay, so going back to our solution here, they lined up exactly on an intersection point. Okay, that's what we would call a nice solution. It works out really, it's something that we can actually solve for because we know exactly where it is. If the solution is not on a nice point, or so where two lines meet, or even if we have to extrapolate in any way, okay, then we have to give the answer as an approximate. Okay, when solving using graphing, okay, at least when we're graphing on paper pencil, approximate values will be accepted or acceptable. Okay, so if we're graphing using paper and pencil, those values will be acceptable. I'm totally fine with that because they are not nice. Okay, we're okay with that. When verifying the solution, plug one variable into the equation and solve for the missing value. It should be the other variable we found. If we have an approximate value, it's going to be close to the other one that we found. So let's solve this one here. We have x plus y equals 8, and y is equal to 1/2 x plus 3. So this question right here, we're going to graph them out. Again, we have two of them, so I'm going to do one in pink. X plus y equals 8. I'm going to switch this over, so this y equals negative x plus 8. Right there. We're not going to work, I didn't make my graph properly enough, so 0, 8 is going to be a point, and 4, 4 is a point. Okay, we're looking for two numbers that add up to 8, so 8, 0, and 4, 4. We're going to draw a line through here. I didn't make my graph paper big enough, and we're going to have that problem next one as well, so we're going to adjust the graph. Okay, so this is x plus y equals 8. And then this one is in graphic form, which is very nice. It's always nice when we have things in graphic form. I'm going to do this one in purple. So number 2, we're starting at positive 3, which is right there. So I should quickly label these numbers. This is 4, 4, and this is 8, 0. We've got a slope of 1/2, so we're up 1 over 1, right there. And when we draw a line through, going to look like that. Okay, so this is y equals 1/2 x plus 3. Okay, so we have our two lines and they meet at this particular point right here. I'm just going to move it out so we have a little bit easier to see. This point right here, now you'll notice it's not right on the intersection point. It could be because I didn't draw it out properly. That could totally be a problem, but I think I've gone through and I've tried to make this as exact as possible. I've tried to do a really good job of it, and it still doesn't meet on an intersection point. We're going to have to estimate what is the x, what is the y. The x is somewhere between 3 and 4, and I'm going to say a little closer to 3, so I'm going to put in here roughly 3.3. Okay, roughly. Okay, and then the y is between 4 and 5. I would say roughly about 4.6. Roughly. So 3.3, 4.6. That's our, because it's not on an exact line, this is an approximate. Okay, there are ways, and we're going to take a look at ways in a little bit of finding the exact answer to that. But when we are graphing something out with paper and pencil like we did here, an approximate value is totally fine. Okay, it is completely fine. It's completely acceptable, and I won't dock any marks if you do that. Okay, so that's what our graph looks like. Let's take a look at the second example here. Now, for those of you that are watching this, it may be a little bit different. I've tweaked it a little bit since I printed. So it might look a little different, but it's still the same premise, and that is just fine. So we're going to do this one here. We have two equations that we're going to do here. We're going to do, this is number one. Let me just double check this here. A quick second. Okay, so number one, we're going to do in blue. Because of the way these equations are, I've adjusted this here, so it's going up by 2's instead of by 1's. So 8, negative 2 is our point. 8, negative 2 is right here. And we have a slope of 1/2, so up 1 over 1 is going to be right there. We're going to draw in our line. There we go. So this is the equation. Y equals 1/2 x minus 8 minus 2. Okay. And then our second equation is x minus y equals 4. So what we're going to do is we're going to subtract x from both sides. Negative y is equal to negative x plus 4. We multiply by y, so y is equal to x minus 4. Go to negative 4, which is right there, slope of 1. And so that is, so we have, this is x minus y equals 4. Now we could always do a table of values as well to solve that. So this is at 0, negative 4. And we have our solution. This is equation 2. Right here. It looks like it's an exact point. It looks like it is at negative 4, negative 8. Okay, that's what our solution looks like. We're going to hope or believe that it is at that point, but that is kind of our solution. Now we had to expand our graph a little bit in order to get that. If we had used the regular one that you see out there, you would then, it would not have worked. So that's just a way of coming up with our actual answer. Now, for those of you that are following along in class, the assignment that goes with this section is LI.07, numbers 1 to 4.